Calculus lesson 7.2, trigonometric integrals. This is part B actually, so we'll be focusing mostly on tangent slash secant x, right? So what is the relationship between tangent x and secant x? So we know that the tangent squared x plus 1 is secant squared x. So we care about the even things. But what's really different about from the previous previous is that I should actually show you this one over here. Sorry. There you go. So we know that the tangent gives you secant squared. That's a little bit different, isn't it? Sine gave you cosine. Sine to the first power gave you cosine to the first power. But tangent gives you second power. So you should make a note of that. And also secant squared, secant x, when you take the derivative, gives you tan secant. So it behaves a little bit differently, right? Yeah. So anyways, and then whatever we do in the tan secant, it's very, very similar to cotangent and cosecant. And this is the derivative that we should know. And we've done this in section 5. So you should be very familiar with this. This one, take a look at how it's derived in the book. It's not very intuitive, right? So you just need to memorize this one, okay? All right. So knowing this, how do you suppose we should do this? Well, we have even over here, do we not? Right? Let me go to the first one actually. So it might be a good idea for you to do, let's say, something like this. Tan squared x secant squared x times secant squared x dx, because if that's du, my u had to be tangent of x, right? Therefore du is secant squared x dx. If that's the case, then that is a u squared, and this right here is equal to what, guys? Tan squared x plus 1, right? That's a u squared plus 1. Do you see that? Yeah, right, so instead of taking 1 out, because whenever you see secant squared, it better be even. Or actually, not necessarily, but you know. It should be even because we're going to be converting it into using the Pythagoras relationship in terms of the tangent, because tangent is u, right? Yeah, just keep that in mind as we do this problem, right? And then let's jump to what I already worked out for you guys, okay? This speeds up the process just a tiny bit more. There you go. So now when we focus on this one, so I've done the work up to this point, didn't I? So that's a u squared, and you got 1 plus tan squared, which can be written as 1 plus u squared. And writing that nice and clean, so you can follow the work, you distribute this, and you do the antiderivative, done. Right? So all the hard work is actually here. Recognizing that I could separate that as a secant squared x dx. And knowing that this is dy, and we could do the rest. All right? Okay. So how do you suppose we should do this? This is not quite as intuitive as it appears, right? So we do know how to deal with the tan squareds. So what we're going to do is separate them, right? So we're going to separate them, guys. There you go. And when I separate them, this could be rewritten as secant squared x minus 1. So when I distribute them, one at a time, that's what I end up with. But I realize, hey, wait a minute. Do I know what this is? Right? This is equal to secant squared minus 1. But I'm like, wait a minute. What is the antiderivative? I know that one. All right? Because of that, I'm okay with these. These are all good. But looking at this over here, it looks very similar to what we did earlier, isn't it? Whenever you have secant squared x dx, so I separated into two, I split the integrals, right? That's a du. Then my u must be tangent of x. That tells me that's u squared. And so that portion right there became u squared, 1/3 of the u to the third, and I substituted for the u value, which is tangent, and I am done. Make sure that you keep the negative sign here. Don't forget about that. And distribute it properly, and we're good to go. Okay. You have to know the antiderivative of secant squared. Okay. So you need to be cognizant of those things. All right. Now, this is a note. Basically summarizes everything that I just said. Okie doke. All right, guys. So we have, for this one, there are two different ways of doing this. And, ooh, what do I notice? I could split that up into secant squared x, dx, and that's du. And my u must be tangent. That's a u. And that right there, guys, is what? U squared plus 1, isn't it? Yeah, that's it. So we have to know our trig identity inside out. So when I make that a little bigger, that's exactly what I did. There you go. Okay, let's zoom in a little bit. Okay, so yeah, so I split them into these two. Recognize that this is du, then u must be tangent of x, and try to, because it's the even power, I could use the Pythagoras relationship to convert it into in terms of tangent. So that becomes u and u squared plus 1 by distributing this expression. U to the third plus u du, antiderivative and substitution, and there's my answer. Okay, guys? All right, so what I'm going to do now is sort of push that aside, right? And let's see what happens, guys. There is another thing that we could have done, right? And that's this. And there you go. Okay. You know what? Let me rearrange this a little bit so I can move this to the side a little bit more. There you go. And here you go. So now, what if I take out one tangent and one secant? That gives you tangent x secant x dx. Then if that's du, then my u has to be secant of x, right? And if that's the case, I'm left with u to the cube. Antiderivative and substitution, and we're good to go. So the hard part about this is recognizing what to take out when, right? And that will become more obvious as we do more practice. Okay? All right. So the example number 4, if I'm not mistaken, I titled it, your turn. So it's your turn to try this problem. Pause the video and see how it looks to you. Okay, guys. So I did it 2 different ways. And here it goes. What happened? Well, in the first one, I just wrote that as a secant squared x. What's a secant squared x right there? And I got tangent of x. I was like, oof, that doesn't look good. So I'm going to take out another secant of x. Then I get tan x secant x dx. That's going to be my du. That means that my u had to be secant of x. So if I did that, that's a u. And I just need to express that in terms of secant, which is u squared minus 1. Having that, I distributed antiderivative and substitution into all this, and I'm left with this. The other possibility is the more obvious choice, which was whenever you have a secant squared x dx, right? Let me make that slightly bigger so you can see it easier. There you go. Let me zoom in a little more, actually. And then what we have over here, this is du, because u is tangent, that's u cubed. And once you're here, you're home free to this. Now, what you should do when you're doing your homework, whenever possible, just do a couple different ways, and then it will really help you to figure out which way is more efficient. Okay? So it's easier to go this way. So what I'm going to do is write that as a tangent squared squared. So what's tangent squared equal to? Secant squared minus 1. So I'm going to square this expression, which gives me a trinomial, and distribute the quarter, and I end up with 1/4 plus c. So 1/4 plus c, which is a constant, the sum of it is also constant, right? So we get this expression, which is exactly the same. So these two expressions are equivalent expressions. Okay, doke. All right, guys. So we have one more example. What to do, what to do, what to do. Okay. I don't like the fact that it's odd. I'm going to pull it out. But unlike sine and cosine, it behaves a little bit differently, right? So I pulled out the tangent and wrote the remaining one as a secant squared minus 1. I distributed them, and here looks very, very familiar, doesn't it? Right? And then that becomes tangent of x, and we memorized this, didn't we? So that's ln of absolute value of secant x. And this right there, let's zoom in a little bit more. If that's du, then my u must be tangent. So we're doing integration of u du, which gives you 1/2 u squared. And u is equal to tangent, so it's a 1/2 tangent squared x. Now, what I did was I put a little star here, the green star. That was an alternate way of doing this. I mean, I would rather do it this way, but it's not wrong to do it another way, right? So, our minds think a little bit differently. So you could have said, hey, couldn't I express this as tangent x secant x dx, and then we have 1 secant over here? Then that would be du, and that would be u. Then we'll end up with u du, and the derivative gives you 1/2 u squared plus c, u substitution, boom. The question is that the same as this expression? Note, guys, I'm only doing the green part right there. Okay, let's make it a little more clear. That is the part that I'm worried about, okay? All right, so what is the secant squared equal to, guys? That's equal to secant squared plus 1, distributed. I end up with 1/2 plus c, which is a c. So this expression is indeed same as this, or it's an equivalent expression. Okay, doke. That is it. And the next page after that, guys, is essentially a summary of what we just did. So it would make more sense reading this after you've done the problems. And then here are some more stuff, the relations that will come in handy for you. Okay? All right, guys. That is it for me. So I'll see you in the next class. Have a good night.